Sorry about the delay on these videos, but here we are, solving systems by elimination. And we cut this into a few days, so I'm going to cut it into a few videos. Let's begin. Solving systems by elimination. We talked about first, like, look, if they gift wrap y equals, let's solve by graphing, where we could throw it in the graphing calculator. Or if they're both like this, or if they give you x equals or y and just one of them, we could do substitution. Even something like this in purple would be easy substitution. Just divide everything by 3, and now I have y equals. So this would be a candidate for, it's just easier to do substitution than elimination. Basically, every other way, elimination is going to be a little bit easier. Here's what we need, though. I know it's kind of confusing, but we need everything lined up. Okay, we need our y's, our equals, our x's, our numbers, like all lined up. So we could have like, you know, a number equals x plus y. As long as everything's lined up, I could do x plus y equals a number, which is usually how we see it. And I don't remember why this is here, to be honest. But what we don't want is something like that, where, oh, well, I can't really line them. If they give you something like this, just switch these back around and just make sure you take the sign with it. Like if this was if this said, go back real quick, if this said minus y, let me get a pen. That said minus y. What I don't want you to do is just this and call it good. That minus is going to have to go with that y. I don't need that. So as long as everything's lined up, we're good. So let me move this out of the way. Solve the system of linear equations by elimination. Okay. Basically, we have these two systems. And what we're going to do is we are going to combine them to make one equation. So what happens here is, and I don't want to say add, because it just depends on the sign. Like this is not necessarily adding, this is subtracting. But when we combine everything, 3 and 3 combine to be 6, 2 and negative 2, and that's why this was there. This is the elimination part of elimination. We're going to eliminate this variable by combining these two equations. And this just gives us 0. Divide both sides by 6. Boom, we got our answer. And just like what we did, we're going to take this, we're going to plug it back in somewhere. And it doesn't really matter where, top or bottom. It looks like we chose to do the top, where it was 3x plus 2y. X is 0, so that's not even there. 2y equals 4, divide, and I get y equals 2. And I get my answer. So every single one of these ends this exact way. We get two equations that we are ready to combine together, and a variable will disappear. Solve for the one that's left, plug back in, and we're good. Here's another one. On this one, we eliminated y. We're not always going to eliminate y. On this one, we eliminated x. We noticed that, look, if I combine these right now, they will be eliminated. So 3, it said minus y, so minus 1y is 2, and then 4 minus 8. And again, this is combined, so you just kind of look at the signs. If it's a positive number, you add. If it's the same signs, add and keep. Different signs, subtract. Keep the sign of the larger one, and you'll always be exact. I mean, there's a reason we taught you guys that in middle school. Solve for the variable left, plug back in somewhere, and solve for the only one that's left. Again, eliminate, solve, and every one of these we're going to get to this point where we can finally combine them together to eliminate and get one variable left. We could solve for one variable, plug it back in, get our answer. Again, I don't think we went through all this. Well, we might have. I don't know why some of it's missing. Apologize for that. This is what we should get. Oh, I did this one in my head. That's why. I had them work on it in class and did it in my head. So just like graphing or substitution, it's possible to get infinite solution or no solution. It's possible for our lines to be parallel or to be the same line. On substitution, we would like combine like terms in a variable the variable that's left would disappear, and so we wouldn't have any variables. It's the same thing here. When we combine both of these, that says -6 and +6, and -7, +7. Both of those actually cancel out. So I get 0 equals something over here. If they do not match, it's a no solution. If it's 0 on this side also, it would be an infinite solution. It's that simple. You combine them if both variables disappear. Now, I think I can go backwards a little bit. I have a lot of students get here and then go, oh, this must be an infinite solution or no solution. No, a variable can be 0 as long as you have a variable. I don't have a variable anymore. That's how you know the difference between the two. On this one, let me move some stuff out of the way real quick. If you notice, if we combine them right now, -8, -8 do not cancel. They make -16. And then we'd have something like this when we combine, and we still got both variables if we combine them. We are trying to combine them to eliminate a variable. If a variable doesn't go away, something's wrong. So just like any equation ever, we can do whatever we want. So we took this equation down here, and I multiplied everything by -1. And I mean everything by -1. Multiplied over here and over here, because whatever you do to one side, you have to do to the other. And I could have added 10 to everything as long as I did it to both sides. Once I do that, basically all it did was take these 3 signs right here, come on, and change them to the opposite sign. So instead of doing all of this work, just know like, oh, I just have to change the signs of everything. If you just change the signs of that and then combine, it's not going to be pretty. Now, it also does not matter if you change the top or the bottom. It looks like we changed the bottom, but if you change the top, you'd get this in purple. Either way, when you divide, you get y equals -6. Once you get your first variable, plug in, get your second one. Telling you, once you're ready to combine, it all ends the same. Here's one that after we changed the signs, it was an infinite solution. But if you look, it was the exact same line twice. It should have been an infinite solution without even really thinking about it. But both of those canceled, just like that. Here's another one where we changed signs. It was 4x and 4x. And as long as you change signs all the way across and combine, you get it. So here's our recap. We are trying to combine the two equations. One variable should disappear. We're looking for same variable, same number, and opposite signs. That's the only way these are going to disappear. 3 and 3 makes 6, but 3 and -3 makes 0. 7 and -7, 10 and -10, whatever. If we have 3 and 3, all we have to do is change the signs of one of these equations. It's got to be all the way across. We cannot just say, oh, I'm going to change that one, but not both of those, and think that everything's okay. So that was day 1. Just making sure you understand we're trying to combine. A variable needs to disappear. We're looking for opposite signs with the same number and same variable. And then we're on to day 2.